Okay, now can you hear me? Just give me a thumbs up. Yeah, okay, sorry about that. So, okay, let's start over. So today we're going to go over 6.4, which is solving rational equations. This section is really probably one of the easiest of the three if you've done the 6.3 homework. It mimics 6.3. Some of the techniques we use to solve mimic how you would simplify complex fractions. So today we should be done. So my goal tomorrow, well, let's see how far we get, and we'll talk about that after class, actually. But anyway, so let's get rocking and rolling. Before I get going, actually, I had some good emails. A few students asked me about tutoring. And I'm going to reiterate what I said at the introduction video. Miss Althea in the tutoring center is the first person I think you should go to. She's on campus. She's free. And it's not that she's free. She's getting paid for the university, but it's coming out of your tuition dollars. So in a way, you are paying for it. So her, and I wrote down her. Let me move my screen over. The email to get in touch with her is tutoring@asumh.edu. So if you want to get in touch with her, if you're having issues now, I believe she can do virtual or face-to-face. So either way is fine. But tutoring@asumh.edu. That's the first contact I would get a hold of. Okay, so today, 6.4, solving rationals and equations. I'm going to really start with an example. The goal really for us, or the way I teach it and the way your book teaches it, is to get rid of the fraction, right? A rational, when you hear the word rational, you need to just think fractions. So our goal is to get rid of the fraction and then solve how we know how to solve. Now, I'll tell you, sometimes that solving part becomes harder than the actual rational part. We'll get to a few like that when we're working on them. But the goal at first is just to get rid of the fraction. And the way we do that is the same way we got rid of complex fractions, by getting by multiplying every fraction by the least common denominator. That's what I was trying to say. So let's look at a basic example first. So if we had, let's say, this is number 4 in your homework. Okay, and these are really just kind of taught the easiest with examples. X over 2 equals 21 over 10 minus x over 5. Okay, so this is an equation, right? It's got an equal sign. That wasn't in 6.1 or 6.3. So therefore, we're going to be solving for x instead of simplifying fractions. And it's a rational because we have fractions. Now, I know that each one of these denominators doesn't contain an x, so it's not a big deal. But we do have fractions, so therefore it's considered rational. So just like before in 6.3, we're going to look at each one of these denominators, and we're going to find the LCD. So the LCD for this one, I'm going to just kind of write it up here. The LCD for this one, well, we've got 10, 2, and 5. Oh, well, 10. 10 is divisible by 10. 5 goes into 10, and 2 also goes into 10. So our LCD for this example is going to be 10. So I'm going to multiply every single numerator by 10. Just like we did with complex fractions. Okay. Now, when we do that, look, I'm going to skip a step here. I'm going to simplify as we go to the next step. So, look, this will be x times 10 divided by 2. Well, 10 divided by 2 just gives me 5x, right? Slash the 10 and the 2, it leaves you with 5. Now, here, the 10 and the 10 would cancel, right? So this leaves you with just 21. And then 10 divided by 5 is 2. So this would be 2x, right? 10 divided by 5 would leave you with 2. Now here, this would leave you with 5. Okay, so that's where it's coming from. So if you choose the least common denominator, and actually even a common denominator work, it doesn't have to be least common. But if you choose the least common denominator, what will happen is all the denominators will go away. Okay, pretty neat. Okay, so then we just solve it like we've been solving it. Add the 2 over. We get 7x equals 21. Divide the 7. And we get x equals 3. Okay. No big deal. Any questions, comments, or concerns about that? So this is the process. we've got to talk about one other topic before we get really into solving when we have x's and denominators. But this is the process we're going to do. We're going to set up the equation. Of course, they're going to give it to us. And then we're going to find the least common denominator, multiply every numerator by that, and then just cancel out the denominator. And whatever's left, is left. And then we solve it out. Now we don't have to worry with fractions. And we solve it out. Okay, so one thing we have to worry about with x's and denominators, I know it hasn't come up yet because we haven't been solving with x's and denominators, are restrictions. Use this word, restrictions. So I'm going to set one of these up. Let's say I have 2 over x minus 5 equals 4x over x plus 1. Why not? Okay, so 2 over x minus 5 equals 4x over x plus 1. And we're going to talk just a minute about restrictions. Okay, I'm not solving yet. We'll get there. But restrictions are values that x cannot be. Okay, restrictions are values that make the denominator 0. Right? They're values that make the denominator 0. Remember, we can't divide by 0. And actually, if you divide by 0, remember this is like in the slope section. If you divide by 0, you wind up with an undefined. Like if this was 2 over 0, this whole fraction will be undefined, and then you can't solve for it. Okay? So we've got to find restrictions that make this denominator 0. And if we have one, that means that x can't be that value. So we might solve throughout this entire fraction or throughout this entire equation. We might get done. And if our x value is for some reason equal to that, we just have to toss it. So let's just start here, though. Start by finding the restrictions. If I look at this fraction to the left, I want to find its restriction. I have to set x minus 5 equal to 0. Because look, if x minus 5 equals 0, we have an undefined fraction. So if x minus 5 equals 0, add the 5 over. We wind up with x equals 5. Look, this is a restriction. Okay? X, and really, the way you should write this is x cannot be 5, right? It should be a not equal to. X cannot be 5. Because if x was 5, if we plug 5 in here, we get 5 minus 5, we'd wind up with 0. And look, we just can't have that. There's no way you can solve this equation if x equals 5, if we have an undefined on one side of the equation. So let's look at the other fraction. We've got x plus 1. I'll put that not equal 0. How about that? X plus 1 can't be 0. We solve for that, and we get x cannot be negative 1. So those are our two restrictions. Now, the question in this section might not ask for restrictions, but you have to identify them because in the end, let's say we solved all this out and the solution was 5. Well, we would just have to toss it because it can't be 5, okay? It just can't be 5. So let's look at an example that we're going to identify the restrictions and then we're going to solve it out. Okay, we're going to identify the restrictions, solve it out, kind of an A-B type question. Number 6. We've got 5 over 3x plus 1 equals 7 over 6. So the first thing I'm going to do, actually, let's do this over here. For part A, no, we'll do it. For part A, we're going to state the restrictions. State the restrictions. Now look, if you've got a denominator with an integer like 6 here, 6 can never be 0, right? Because 6 is not a variable. It doesn't vary, right? It's just 6. It's a constant. So we don't have to worry about the 6. We don't have to worry about the 1. Remember, it's 1 over 1. The 3x we have to worry about, though. 3x cannot be 0. If we divide the 3 over, turns out x cannot be 0. So I found part A. Look, if we wind up solving this whole thing and we get x equals 0, we just have to toss it. And we'll do an example like that. I don't think it's like this one, but we will do one. So part B, we're going to solve the equation. Okay, let's go back to the equation. Look, really remember you can think of 1 as 1 over 1, right? Because it's an integer. So we have 3x, 1, and 6. We've got to find the least common denominator. Well, with the numbers, we've got 6 and 3. That's kind of easy. It's 6. 6 goes into 3, 3 goes into 6, right? So we're good there. But we also have a variable. So we're going to put the x in there to get the x to go away, right? So I'm going to multiply each numerator by 6x. Okay. Each numerator by 6x. And let's see what happens when stuff cancels, okay? This first fraction here, 6 goes into 3 2 times, and then the x's go away. So you just wind up with 10, right? 5 times 2. 6 divided by 3 was the 2, so 5 times 2. Plus 6x, right? 6x times 1 is 6x divided by 1 is 6x. Equals, now here the 6 goes away, but you're left with 7x. Oh, neat, okay? I think we'll get this answer in one step. But notice all the fraction went away. It left us with a really basic equation. You just subtract 6x over. And you're left with x equals 10. Hey, you know what? X equals 10 is not a restriction. So we're good to go, okay? It is not a restriction, so we're good to go. X just equals 10, and we're done. Pretty nifty. Okay? So let's look at one where we might have, oh my gosh, they dump us off in the deep end. Hold on. Let's look at one with a binomial now. Not a big deal. Let's look at one with a binomial. Hold on, I'm going to steal an example maybe from the book. Okay, yeah. So let's say we've got x plus 6 over x minus 2 equals 2x plus 4 over x minus 2. So what's nice about this one actually is both these denominators are the same. That'll be helpful. But I'm going to put parentheses around anything with an addition or subtraction in the numerator or denominator. Notice if you go back, none of the examples we've done so far have had addition or subtraction in the numerator or denominator. And just like before in 6.3, I'm going to put parentheses around it before I get started. So I don't, look, so my brain doesn't cancel 2x and x and 4 and 2. No, you can't do that because it's a whole parentheses, okay? You have to be the exact same in the top and bottom. Okay, so what to do next? Oh yeah, let's say the restrictions. Well, it's the same denominator, so we only have to write it once. X minus 2 can't be 0, so x cannot be 2. Okay, so that's my restriction, and they're the same, so I'm just not going to write it twice. So part B. Part B, I've got to multiply both sides by the LCD. Well, there's only one LCD, right? There's only one denominator. The only denominator is x minus 2, so I've got to multiply that on both sides. You know, it's an equation. As long as you do it on both sides, you're fine. I guess I didn't really state that earlier, but as long as you do multiply on both sides of the equation, everything on both sides of the equation, then you're fine. And what's nice about this one, check this out. This whole denominator just cancels with that thing we multiplied by. Same here, because it's the exact same. That all goes away. And you're left with x plus 6 equals 2x plus 4. Okay? So let's solve it out now. I'm going to subtract the 2x. Negative x plus 6 equals 4. Subtract the x, and I get negative x equals negative 2. And then I've got to divide by negative 1. Hey, wait a minute here. I wind up with x equals 2. That's not a coincidence. I wanted to choose one that did this, okay? I wind up with x equals 2. What that means is it's a restriction. I can't do that. If I put x equals 2 into that original equation, you'd have an undefined equals an undefined. We can't have that, okay, because it's undefined. So therefore, even though we did all that work, we're going to have to just toss it out. And we're going to say this is actually a no solution. There's no solution. There's no value of x that can satisfy that equal sign. So the way you write that is you just write a circle with a line through it. It looks like a 0, it's not, but it's a circle with a line through it. And it means no solution. Okay, it means no solution. Okay. Just chime in here, Kinley, if you got a question. Okay. So let's do ones that are a little more complex. What if we had, let's see here. Yeah, what if we had, so this one looks kind of similar, but you'll see this is 14 in the homework. Kind of similar, but different. So we get 6 over x plus 3. Now I'm going to put parentheses around that. Equals, I'm going to write these kind of spaced out because I know it's going to be multiplying on the top and bottom. X minus 3. Okay, 6 over x plus 3 and 4 over x minus 3. Okay, well, our LCD here, now these LCDs are really easy to find. They're just going to look real bulky, okay? Our LCD on this one, look, these are different denominators. X plus 3 is not the same as x minus 3. So we're just going to multiply them together. Because listen, like this little, two binomials multiply together. That x plus 3 will cancel that one. This x minus 3 will cancel this one, okay? So we just multiply them together and we get the LCD. So look, 6 here, we're going to multiply by x plus 3, x minus 3, and 4, same thing, x plus 3, x minus 3, okay? So same operation, you're multiplying the tops by the LCD, and then we just get rid of the factor that matches, right? The x plus 3 over here, and the x minus 3 over here. So that leaves us with 6 times x minus 3 equals 4 times x plus 3. Okay? So the fractions have gone away. So, oh, you know what? We didn't state the restrictions. Hold on. Let's stop right here. I should have done that. Restrictions, well, if x plus 3 can't be 0, x can't be negative 3, right? Now, if x minus 3 can't be 0, then x can't be a positive 3. So negative 3 and 3. We can't have negative 3 and 3 if we wind up working this one out and getting that answer. So let's multiply the 6 through. We get 6x minus 18, okay? Then multiply the 4 through, we get 4x plus 12. And we just solve it out. So subtract the 4x, and I get 2x minus 18 equals 12. Add the 18, and I get 2x equals 30, right? And divide the 2. Now I wind up with x equals 15. Hey, that's not a restriction, so that's going to be our solution. Okay? That worked out well. Kind of neat, kind of cool. Okay. That up for just a second. Okay. Let's look at another one that's just a little more complex. Okay. This is number 12 in your homework. Number 12 states 1 over x minus 1, parentheses around that, plus 1 over x plus 1 equals 2 over x squared minus 1. Okay, so if I get one like this, I'm going to, if I can factor, I'm going to factor a denominator out completely if I can. And this x squared minus 1 factors, it's a difference of squares, right? Section 5.6, difference of squares, okay? X squared and 1 squared. So we can rewrite this as 1 over x minus 1 plus 1 over x plus 1 equals 2 over, this factors as x minus 1, x plus 1. Hey, that's what's over here, okay? So now I'm going to state my restrictions. Let's solve it out, and then I'll state my restrictions. We'll check, okay? We'll do it that way because I've got this nice flow going. So the question is, well, what's the LCD, right? We got to multiply the LCD to everything. Well, the LCD for this one, look, we got x minus 1, x plus 1 as factors, and then they're multiplied together here. So all we have to do for the least common denominator is just multiply those two together. If we multiplied each numerator by this x plus 2 and x minus 1, at least something in here would cancel these two denominators, right? X minus 1, that one, x plus 1, that one, and then the whole thing here, okay? So I'm going to multiply each one of these by my least common denominator, okay? So I'm going to multiply each one of those by my least common denominator, and then I'm just going to cancel. So x minus 1 goes away, x plus 1 goes away, and then they both go away, right? Now over here, this leaves us with 1 times x plus 1 plus 1 times x minus 1, which equal, oh, just 2, right? 1 times x minus 1 plus 1 times x minus 1 plus 2. Okay, so the 1's go away, right? If you distribute the 1, this just winds up being x plus 1 plus x minus 1 plus 2. X plus x is 2x. 1 plus a negative 1 is 0. So you get 2x equals 2, divide by 2, and you get x equals 1. Hey, hey, hey. That wasn't too bad. It was really weird looking, real bulky at the beginning, right? But it wound up not being that hard to solve. Now, let's go back and do these restrictions. Now, remember, we got to look at each denominator. So now what's nice is we've got x minus 1 can't be 0. Oh, crap. That's not good. X can't be 1. We got to toss that out. X plus 1 can't be 0, so x can't be negative 1. But look, those two factors are the same. So we don't have to set these equal to 0 and solve because we already did it, okay? So these are our restrictions. And if you notice, one of our restrictions matches our solution. So we've got to toss it out and put no solution, okay? Oh, bummer. We did all that work, and it turns out it's just a no solution. Okay, let's keep moving on. I'm going to do another example. I think that winds up, this example, I believe the solving winds up being a little more difficult. So let's see if I'm right on that. This is number 22 in your homework. 22 in your homework. We get 12 over 3x squared plus 12x equals 1 minus 1 over x plus 4. Okay, so I'm going to do the restrictions first because I forgot to earlier. Restrictions. So 3x squared plus 12x can't be 0. Well, hey, you know what? This factor, so I'm going to factor 3x out, and I'm left with x plus 4 can be 0. This is 5.76 or 7, I forget now. It's the solving trinomials, right? Solving polynomial section from the last test. And notice x plus 4 is here and here, so we won't have to do this twice. So I'm going to say 3x can't be 0. Divide the 3. Turns out x cannot be 3. Or can't be 0, not 3. X plus 4 can't be 0. So x cannot be negative 4. Okay, so those are our two restrictions going on. Let's just simplify this. Okay, or actually let's solve it. So again, before we solve, just like the last equation or the last fraction, we need to factor this completely. Now what's nice is we did it over here, okay, whenever we found the restriction. So we get 12 over 3x times x plus 4 minus 1. I'm just going to write it as 1 over 1. It helps me. Oh, no, equals 1 over 1 minus 1 over x plus 4. So our LCD here, we're going to look at common factors. Look, there's a common factor of x plus 4 in both those. There's a 3x over here. So it's just 3x times x plus 4. Now we don't have to worry about the 1 because we don't have to cancel a 1. It's no big deal. But the 3x and x plus 4 will cancel this entire denominator, and it'll cancel the x plus 4 over here. So we're good. So I'm going to multiply both these, or every single one of these, all 3 of them, by 3x and then x plus 4. Okay, so this first fraction, when you multiply every single one, 3x times x plus 4, and so on. Now that's not 13, that's a times. Same here. So when you do that, this first fraction here, it's going to cancel, right? The denominator cancels everything out. So you're left with just 12. The second fraction, well, actually, it's just a 1. So we're multiplying this by 1. So it's going to leave us with 3x times x plus 4. And then the last one, we get rid of the x plus 4. You're left with minus 3x. Don't forget the minus sign. And then you've got 3x left over. Okay, so now we've made it into something that we can solve. That's definitely more manageable, and it's definitely, I'm going to check. I think it's 5.7. Yeah, 5.7. It turns into a 5.7 question where you're just solving a polynomial, solving equations. Okay, polynomial equations. So let's distribute the 3. We get 12 equals 3x squared plus 12x minus 3x, right? If we're going to solve this, I've got to get 0 on one side, so I'm going to move the 12 over. And because I have a positive 3x squared, we'll subtract 12. Those add together too, don't they? So we get 0 equals 3x squared. Now, the 12x minus the 3x, that gives me minus 15x. And they've got a minus 12 on the other side, okay? So now look, we got 3x squared minus 15x minus 12. And what's nice about these 3 numbers is they're all divisible by 3. So I'm going to divide everything by 3. Put this up here. So we get 0 equals x squared minus 5x. Oh wait, it's a plus 5x minus 4. Did I mess up on a sign? Oh, I messed up on addition. Oh my gosh, look guys. 12x minus 3x, that's not 15. That's 9. Still divisible by 3 though. So I'm going to rewrite this one. See that 12x minus 3x, I said it's 15x. It's not, it's 9x. So I still move the negative 12 over. So I'm going to divide this all by 3 still, but we wind up with 0 equals x squared plus 3x minus 4, okay? And this is factorable. So I'm going to get x. Remember, this is the easy factoring because x squared is by itself. I got to get it to add up to 3, multiply to give me negative 4. It's going to be a positive 4 and a minus 1. So I set each one of those equal to 0. X equals negative 4. X minus 1 equals 0. X equals a positive 1. Man, look at all that work. Guys, we started up here, and we went all the way down here, and then we looped all the way down, and we did all that work. So it was a 6.4 question here, right? Really a 5.7 question here. And then it turned into a straight up 5.7 question. Solving trinomials by factoring is a 5.7 section question. And then we get to these 2 answers, but one of these we have to throw away, right? Negative 4 is a restriction. We can't have negative 4 as a solution. So it's got to go away. Okay, so the only answer we have for this equation is x equals 1. Okay, cool. Seeing if there's, oh God, yeah. She's throws some weird one. Gosh, I can't stand it. I just don't understand. Actually, this is a great book, guys. I know this, you're gonna have to take me for my word on this one, but like we've used a lot of different books, and this one is a few editions older because it turns out math doesn't change, and but also it's just a really good reference material book. But there's just certain things she likes. And one of them I know I've joked about already is that this trick that we're about to use. So this is 38 in your homework. 2x plus 1 over 4 minus x equals 9 over. Oh, wait, no, we don't have to do it. 4 minus x. Well, never mind. I don't want to do that one. Never mind. Is it not going to pop up? Here she would use it here. She's used it in every single one. Nope, I guess not. Never mind. We've done one like this already, right? We've done every type of example. This is just not a long section to lecture on. Now, I'm going to tell you it's not the easiest section to do, but it's just not the longest section to lecture on. So for homework in this section, 6.4, for homework, we're going to do number 1 through 47 odd. 1 through 47 odd, 6.4. This is on page 468. Okay, on page 468. So really, okay, I'm going to leave that up for a minute. So homework 6.4, section 6.4, 1 through 47 odd, and then it's on page 468. Let me bring this up real fast. Hold on. Make sure we're on track here. Schedule. Okay, so I'm going to share my screen real fast. And if you see here, you can tell it's the schedule for the semester. Now we're on week 4, which is crazy. And we're definitely over halfway done. But tomorrow, notice I set aside 2 days to work on 6.4. And it really wasn't 6.4. It was if 6.1 or 6.3 took us too long. But we got through all those sections. So what I'm going to do now is for tomorrow, for Thursday, we'll just have a review. But I'm going to have class start a little bit later. I know that I have one student that shows up every day. So I'll send an email about that. Email about late start. Because what happens is I'll do a little review, and it's just going to be based off your questions. So if you guys have questions, email them to me. If not, don't worry about it. So get the homework done and then email me questions, or you can come to class, and we'll start at 8:30. Okay. So tomorrow's class is going to start at 8:30 on Thursday. Okay. So 8:30. Tomorrow's class starts at 8:30. So I'll send an email out too about that. So we're just going to review, and then it'll be based off your questions from section 6.1, 6.2, or I'm sorry, 6.1, 6.3, and 6.4. Okay. How do I get off share mode? I thought there's a button that you press and give me 2 seconds, guys. It doesn't have that. What in the heck? Oh, there we go. It's way over here. Okay. So there we are. So tomorrow, Friday, February 4th, 2021. So if you're watching this later on, realize it's not that day. But we will be starting class at 8:30 instead of 8 o'clock. Okay, so if you wind up coming into class early, that's fine. You can hang out. But I'll tell you this, these reviews never last that long. And if you want to stay later, that's